Next Curve.
Hey everyone, welcome to this episode of Next Curve's reThink podcast and our special series, Silicon Futures. And I'm Leonard Lee, Executive Analyst of Next Curve, and I'm joined by Karl Freund of Cambrian AI Research. And we have shoot all your bullets before you hit the record button, Jim McGregor of the famed, neuromorphically augmented Tirius Research. How did I do? Pretty good.
Pretty good. Hey, I'm the Southwest I'm the cowboy. I'm
Yeah.
I'll admit that. I'm the cowboy here.
Yeah, he's quick to the trigger. You know, he's trigger happy. Oh my gosh! Folks don't even know. They don't know what happens before we hit the record button.
As I was called one time by a reporter, I was called the outlaw analyst. So
I buy into that 1000%. Okay. So in this episode, we're going to be talking about the hot headlines of the month of April. And of course, this is 2026, if you don't know the year. And before we get started, please remember to like, share, react, and comment on this episode. Also, subscribe here on YouTube and on Buzzsprout to listen to us on your favorite podcast platform. Opinions and statements by my wonderful guests are their own and don't reflect mine or those of Next Curve. And we're doing this for informational purposes only, to provide an open forum and debate. And we shall have a debate in this episode on all things AI, quantum, right? And semiconductor, semiconductor industry stuff, chips, and all these things that we love so much. And so we're going to get started, and we're going to start off with Jim's favorite target of the month, the CPU and AI. So why don't you explain to us what is going on? Why is everyone going bonkers about the CPU in the world of AI computing?
Well, there is the theory that especially CPU performance increases and the AI models get more efficient, then you're going to be doing more of the AI processing on the CPU. Now, I will agree that I do think CPUs will evolve over time. Matter of fact, we're starting to see, new instruction sets out of the AMD and Intel partnerships that will lead to that. Obviously, you've got other vendors like IBM that have integrated an NPU directly into their CPU. You also have that, especially on the mobile side, with companies like MediaTek and Qualcomm. So I think that over time you will see more AI workloads running on the CPU, but I don't think there's a major shift. And I think that's kind of the message we've gotten from a lot of people is that, oh, well, you can run everything on the CPU. Well, if it's not really designed for AI, it's still basically going to be that orchestration engine. Matter of fact, that's what we're seeing, especially with a lot of the ARM processors with Grace and Vera from NVIDIA, as well as the AGI from ARM. They're designed to be that orchestration processor. Could they run AI workloads? Yes. Are they designed to run AI workloads? No. IBM probably has the best balance where they have that AI accelerator on the CPU and they have the AI accelerator, separate discrete accelerators, so they can kind of divide the workloads. But I don't necessarily see in the data center, I don't see a lot of the AI workloads moving to the CPU. I do see now. I do think that especially as you have more inference processing, you may need more of that orchestration power tied to the AI accelerator. But the AI accelerator is still going to be more efficient no matter what it is. But I think as you move closer to the edge, where you're not necessarily going to have that AI accelerator, that's where it makes sense to definitely run the AI workload on your CPU.
So I think I would take issue just a little bit because I don't think people are saying you're going to run the AI on the CPU. What they're saying is that agentic AI requires a heck of a lot more orchestration and planning and scheduling and all the work that goes on around the AI models. uh, that's what I'm hearing people say, is that the agentic AI shift is adding more workload to CPU. And in fact, some folks have claimed, instead of having, let's say, a one CPU to eight GPUs, one or two CPUs to eight GPUs, it's going all the way down to 1-to-1 ratio, where if you'll need a CPU for every GPU or whatever your accelerator is. And so that's what's driving the increase in CPU, which is benefiting Intel clearly. I think will benefit NVIDIA with the Vera Rubin platform, where you've got a really good CPU that's doing all this, upfront and in between work and ongoing work. Remember, agentic AI is running 24/7 in the background. And what's running is a combination of CPUs and GPUs.
See, I agree with that statement, although the 1-to-1 I don't agree with. I think maybe 1-to-4 makes more sense.
One or maybe 1-to-2.
1-to-2, but 1-to-4 makes a lot more sense and more efficient. But I think that some of the market and some of the industry, especially Wall Street, is taking that message way too far.
Well, it'll be interesting to see. Interesting to see what Qualcomm announces, because they haven't really told us much what's going on, right? At Qualcomm's quarterly earnings report, Anand, CEO, Cristiano Anand, said that he's got a hyperscale customer for whom they're building a custom rack solution. So I think this is a sign of the further specialization of AI for specific workloads. So if you could imagine somebody like a Meta or Amazon or Neoscale, Neo hyperscaler, having a competitive advantage because they and only they have access to a custom processor that solves some particular problem. Maybe it's recommendation engines, maybe it's video. I don't know. But that can give you a competitive advantage, drive increased margins, increased revenue, because you have that. And I think we're going to see a lot more of that kind of specialization. And I can't wait to see what they're doing. We'll have to wait a couple of months, maybe.
And I think that's kind of the message for the month. Because we've seen a lot of announcements. We saw Qualcomm announce that they're doing custom CPUs and AI accelerators. Don't know what the announcement is that they're going to make around their financial analyst conference coming up in June. We've seen Google, who I don't know if I want to be their partner right now. First, they announced 2 new TPUs for training and inference. Then they announced a partnership. They enhanced their partnership with NVIDIA. Then they announced that they're going to sell the TPU to select customers. So, but we've seen, Amazon/AWS. We've seen Microsoft. We've seen everybody kind of enhance their story around their silicon, especially for inference, but also for training. Even yesterday, Tens Torrent had an event talking about their black hole processor and their Galaxy clusters that they're going to be able to provide that are completely air-cooled, custom AI, or I should say specialized AI solution. So I think that, it's still AI, and it's really driving the silicon message right now.
Yeah, even to the point of some companies providing silicon for a specific model, right? Thales, for example, they've released a chip that only does one thing, and that is Meta Llama. It's a small model. Is it
7 billion?
7 billion. Yeah. So it's only for small models right now, but their vision is that they're going to have a custom piece of silicon, and that will run a model just for you. That's all it will do. And you're going to have to upgrade that CPU, the processor, every time that model changes. But that's all baked into their financials. And it's still massively cheaper and more productive. Question: will people adopt such a rapidly changing infrastructure?
Well,
the idea of specialization, I think, is the key to the month of April.
And then also longevity. A lot of developers can't keep up, and they don't want to keep up. They want a baseline, and they want to be able to live with that baseline for a really long time.
That's not going to
If
happen.
you get closer to the edge.
I disagree.
Yeah. Oh no, I hear
I agree
the
with you.
developers.
I agree with you, but I don't think it's going to happen.
No.
Oh no, it won't. It won't happen. But I think that demand is going to change the demand profile for technologies and products that support longevity, right? Versus things that are on a very, very fast cycle. And so I think with inference, we're going to see a different cycle, especially if as you get into enterprise, than what we see in model training, right? What all these AI labs are doing. That's a different game, different velocity than what enterprises are going to be comfortable with.
Yeah.
But what more importantly, what infrastructure players and service providers are going to be comfortable with. They can't keep up. They can barely make the shift toward cloud native. You're going to introduce another. You're going to basically introduce a turbocharger on top of something on a whole field of technology that they can't absorb. I think at some point there's going to be a digestion issue, right? And I think there's probably already a lot of that factored into some of the slower adoption we're seeing in the infrastructure. You know, these autonomous infrastructure narratives and expectations. It's not going as fast as people think, right? And when you do, like if you look at telco, it's not getting absorbed as quickly. We're still like at level 3 autonomous XYZ versus like level 4. Level 4, we've been talking about level 4 forever. And it's still a challenge. And it's usually still a very narrow enablement. But I want to go back to Google really quick in your comment about the CPU for agentic. And I think that is the big theme shift that's happened in the last 6 months. And, you know, I see the role of, I agree with both of you on the different layers that you've described in terms of the role of the CPU, but there's another role that people don't talk about, which is what actually hosts an agent and what does the entire agentic system look like? And the reality is a lot of it has nothing to do with AI. A lot of it has to do with traditional compute functions like hosting the container for the agent, right? And so, you know, basically now what we heard coming out of Google was that they partnered with ARM to, be able to support sandboxing, right? Secure, what I call zero trust execution containers in a very similar fashion to Nemo Claw, what we see with Nemo Claw. But, you know, these things don't just appear out of nowhere. You need compute, and that's going to run on a CPU. So as we see, these claims of billions of agents being deployed out there and running constantly, well, guess what? You're going to need CPU to instantiate, support, and provide a runtime for those agents.
In my mind, that's all part of the orchestration.
Yeah.
There's the orchestration is more of a control plane function in my view, and then there's the physical stuff there's that let's call it the fabric, right? The hypervisor that you still need to implement, right? Whether it's serverless or it's container based. So that's traditional cloud computing requirements. So when we start to look at agentic, it's a blend of accelerated, quote unquote, accelerated computing and traditional computing. And a lot of the tooling is going to be orchestrated and managed by functions that are likely going to run on a CPU. And then all the tools, most of the tools, especially the stuff that hits backends, those are going to be, like traditional data center backends. So most of that is running on CPU. So I think, that's where we can expect a broader demand for CPUs, and I don't think that that's what Wall Street's reacting to, because a lot of the folks that I talk to don't recognize this because they're still focused on the AI computing element. They haven't extended their thinking out toward what this holistic view on what the agentic system looks like.
I think we need to redefine this because yes and no. I mean, if you look at the CPU as the entire SoC, then yeah, it's going to continue to gobble up more blocks. I mean, like in the data center, you mentioned everything has to run on the CPU. That's actually not true because we're seeing the emergence of the DPU to offload a lot of that overhead workload, for security, for network management, for stuff like that. And quite honestly, could that DPU eventually be kind of a function, a hard-coded function within a CPU or within a processor or an SoC as one of those functional blocks? It could be eventually, So I think that, we still end up going towards more customization to do each specific workload, each specific task.
Oh, yeah,
And to your point about zero trust, in some cases, that's actually a separate functional block. So if you look at like some of the, mission critical applications for automotive or mil-aero or stuff like that, they actually have separate blocks that are zero trust blocks that, make sure that there's no bleed over between applications, between data, between even IO to ensure that that is completely zero trust.
Right. But then that's kind of like that secure enclave type of
very
concept.
much so.
But I'm talking about levels above it. And so what kind of computing requirements are at closer to the software and application level that are driving demand? And so that's where you really have to look holistically at how are we evolving from LLMs, standalone LLMs, to agentic systems. And so when you look at but you're making a really cool point about the CPU and how the CPU itself is not just the cores. When people think about, we run it on a CPU, they think of like the cores for some reason, right? It's the CPU cores. But to your point, there's a diversity of cores that we're seeing now. Some of them are application specific. I mean, you have ASICs embedded in like a package, co-packaged into a CPU, a CPU, right?
So I think we shouldn't miss mentioning the big picture of this whole trend, which is that everything we're talking about is very complex. And if you add to that the thought that you're going to be turning the silicon very rapidly, all of this is going to drive increased growth in cloud computing. Nobody wants to manage the myriad of SKUs in their data center if you're going to be taking a problem and breaking it up in lots of different pieces, each one with a specialized processor or CPU or GPU or ASIC or whatever. They don't want to deal with all that stuff. And so increasingly, I think enterprises will now shift even more rapidly toward cloud computing. If you look at the earnings announcements last week, we saw tremendous growth across all cloud computing platforms, and it's lifting all boats because the neo clouds are also absorbing a lot of this bandwidth requirements. So I think cloud computing will increasingly become the utility of the future. And the thought that you have to stand up your own data center, that's going to become obsolete.
Well,
with a few exceptions.
And I think that especially what Leonard's trying to describe is what I call kind of workflow processing, where instead of thinking about platforms, you have to think about workflow. And my best example on this is physical AI, where you have to think about what you put on device because you got limited power, battery, processing capabilities, what you put in the network, what you put in the cloud. And I think overall we are moving there. And I think that's one of the biggest changes, and quite honestly, that's changing drastic requirements for networking technologies, just to be able to handle this. But we have to start thinking about a single workflow that may cross all of those. It may cross the device, it may cross the network, and it may be in the cloud. It may be all three of those working together, and understanding that is a huge challenge. It's no longer a platform play. It's really a workflow play.
Yeah. I agree with you on that. And that, for the most part, is a big missing piece. And it's funny, There's still people talking about chips and these companies selling chips. No, they sell systems.
Yes.
At a minimum, if not like an entire cluster, right? We've said, Jim,
and the software and the tools and everything else.
You're literally like for Google, when they ship these TPUs, it's not just the chip, and that's not the hard part. They already have generations and generations of TPUs, right? I mean, well, stop me when you when I say something wrong. And so the DNA that they have is basically delivering not only their model specific, right? The Gemini stuff, the stuff is optimized for Gemini, and generationally optimized AI compute stacks, right? And then the software, all this stuff evolving together. And this is something, Karl, you especially tuned into and highlighted, I think about almost 9 months ago, right? When we were at Hot Chips, right? You got really excited about TPU all of a sudden. But I think that it's an important point for everyone to tune into, because I still see a lot of commentary out there in the media as well as in the investor community where they're still fixated on the chip. And it's like, no, you probably should be thinking about networking more than the chip.
Well, maybe you should be thinking about memory and storage instead of the
storage.
Boring old storage. Look at SanDisk. This is top performing S&P 500 stock. SanDisk, right? Really? Yeah. And guess who's like number 3 or 4? Micron, all right, which provides both a geopolitical hedge as well as a necessary a memory needed for high performance computing and AI. They're eating it up. I mean, they're just they're sold out through 2027.
And it's a whole data layer that's I mean, and it's constantly changing. I mean, we didn't have SoCal until last year and just became a standard this year. SoCam, sorry. But SoCam.
I live in SoCal.
Exactly. SoCam. But the fact that you have to think about, how you cross from SRAM to HBM to DRAM or SoCam to DRAM to, storage, blah, blah, blah. It's an entire data layer.
That data layer is what has become the fastest growing segment in the landscape, as well as the new choke point. And as it becomes a choke point, guess what happens? There's not enough supply. So what happens to prices? They go up. They've doubled. They've literally doubled in the last 12 months just in prices. So margins explode because instead of running a 40% gross margin business, you're in a 50 to 70% gross margin business. So that level of infrastructure, the data layer, has become the hottest part of the market.
Yeah. I got a question for you guys. Our industry is still charging along. I mean, despite the memory issues. I mean, we're seeing, maybe pullbacks in some of the smartphone announcements, or the number of SKUs being offered and stuff like that throughout the year. But our industry is still cranking. I got to ask you a question. Do you really think that from a global economic perspective, we can keep this up? Because we've got Iran. I mean, even looking at semiconductors, we still need a lot of helium out of the Middle East to be able to do advanced semiconductor manufacturing. And I'm just looking at this between tariffs, between cost of everything going up from food to chips to systems. I'm just like, I don't believe this is sustainable.
Yeah, I mean, I think there's the constraints, right, from a supply and manufacturing perspective. What is your ability to at a global scale meet the perceived demand? But then on the other end, I mean, I think one of the most telling moments during the earnings season was a question an analyst asked Amy Hood and Satya Nadella. And they asked the question, so they asked the ROI question, who's going to pay for all of this? How is it going to be paid for economically? And they still couldn't give a good answer. It's still more of, it's all the hypothetical stuff. And I'm not picking on Microsoft, but pretty much with maybe the exception of Google, it's still difficult to tell because, it's one thing to look at surface numbers. You have to really drill down into the financials and then try to look through and see through the murkiness of some of the AI numbers, right? Everyone claims they have massive AI numbers and growth, but then they're not very transparent about it. You have to guess what it is that's actually happening underneath that number. But maybe with the exception of Google, because I think, honestly, they are probably best positioned to drive some degree of monetization. But that's advertising stuff, right? That's not productivity in terms of pumping out widgets or shipping bushels.
I would take a little different view. And that is, if you look at various segments, let's say the consumer segment, where agentic AI is finally going to give people the productivity tools that AI has been promising for a decade now. So that is hitting an inflection point and will drive increased demand. Another segment is in programming, where you need fewer and fewer programmers to get the job done. So layoffs are coming, and because the ability of AI to write code is pretty astounding. I asked my favorite, Perplexity, to do all kinds of things for me now. And you know what it does? It writes programs to do those things and links them all together for me. And all I had to do is ask it to solve a problem. These are going to have massive productivity improvements. Now, another segment would be in very specific markets. Let's say in genetic based drug discovery, where we're starting to see some very significant drugs come to market that will have a huge impact on the marketplace. So I kind of view it differently, Leonard. I view it as each of these segments is hitting its stride at about the same time. And that's going to drive the economic benefits that everyone's been asking for, justifiably.
Yeah.
But to your point, and I agree that we're having these innovation waves. But if you're laying off very high priced talent, does that also have an impact on the overall economy?
Absolutely.
Elon thinks that everyone's just going to get a universal income. I don't see any company paying that anytime soon. So I mean, if all of a sudden we see unemployment going up because of AI, if we see geopolitics limiting our industry and capacity limiting our industry, and let's face it, the tech industry has been kind of the bright spot of the overall economy for 2026. I'm looking at this and I'm still thinking that I know, and I'm not an economist, but I do track the economy, and I'm still looking at this and saying I'm still very fearful that towards the end of 2026 we could be looking at a recession.
Yeah, well, like Vertiv, companies like Vertiv, Jabil, companies that are contributing to the infrastructure build out that are not tech. These aren't intrinsically tech companies, right? They might call themselves tech now because everyone
they are
a tech company. I know. I mean, but you know what I'm saying? That's why I hate the term tech.
They just move fluids instead of electrodes.
Fluid company, dude.
PCBs. They build systems. They build power solutions.
It's amazing when you go to these tech conferences now and they start looking like plumbing shows.
Yeah, exactly. Exactly. Oh yeah. And then now you're gonna tell me
or power shows. Yeah.
You're gonna tell me full plate is tech.
It is tech.
Oh,
it is tech.
Okay. All right.
Okay. Where's that slap button I was looking for?
No, we still have to invent that. I mean, maybe Karl can get Perplexity to code that.
Ever could.
What was that in the background?
I was trying to find a slap function that I got.
Slap function.
Okay. Hey, I wanted to ask you both a question really quick because there seems to be like a lot of fascination about the fact that Google has two rack systems and they have a TPU 8i and a TPU 8t. Why don't you explain to everyone what's really going on here with, let's call it this split? Not really splitting the chip. There's really just creating two variations
Well, when
of
if you look at it
radix.
at a system level, down to the chip level, everything for inference is going to look different than it does for training. You can still
Yeah.
do inference on a machine that's designed for
Yeah.
training, but it's not as cost effective as one that's really designed to solve the inference problem,
Yeah.
which has, as we've learned, there's not just inference. There's the decode segment, and then there's a prefill segment, and oh, by the way, you can even take the decode segment and split that into two, which is what NVIDIA is doing with the Grok language processing. So the problem you're solving is as it continues to change, it needs specialized hardware and specialized software for the orchestration of taking the inference process and splitting it out and disaggregating it across different properties of very different architectures. Now, TensorTorrent disagrees with that. Jim Keller was quite explicit yesterday when he said, hey, guess how many people are going to be doing disaggregation by the end of 2026? He said zero. That's a very profound statement. And if he's right, you're going to see change in leadership in the hardware industry. So the specialization, as we started this whole conversation, the specialization continues to expand, and I personally think Jim is wrong, and that the specialization will produce more cost-effective solutions. However, if he's right, and a single architecture can do a better job if you just let it do the job instead of doing all this orchestration, split the job up in multiple workflows. That would be economically very powerful if Jim is right. We'll see. Right now, they haven't published any LLM data. They've only published video data,
But in Jim's
video benchmarks. But wow, video is impressive.
Really, in real quick defense of Jim, and I don't know if I'm going to be defending you.
That's here, Jim Keller, not Jim McGregor.
Yeah, no, but Jim McGregor is that, it depends. Inference and model training will be categorically different. And so, I think the treatment of your comment probably is going to be different in those two categories. My view is that NVIDIA is still, the dominant force in model training. As soon as you get out of that, then inference starts to look a lot different, especially if you have generational model to hardware alignment efficiencies and optimizations that you can engineer, like what Google's doing, what Microsoft is doing. And we're seeing these transitional shifts in the architectures as well as the chips themselves as they try to make this, a shift over toward inference, right?
I would link this to where we are. And, there's technology cycles that we go through. When you're in a early period of the cycle where there's constant innovation, constant change and everything else, it's really hard to put things into a hardware, a single hardware solution that satisfies the whole thing, because standards are changing, especially with AI. Models are changing, how we process models, where we process models, all that's constantly changing. So I think that's still driving a huge amount of innovation. We're nowhere near that kind of maturity stage where it says, okay, well, now we have kind of standards and let's design around those standards, and we're not there yet. I think that there's some key message to, it would be great if we had something that could do everything. But just look at the number of companies that are now offering custom silicon. First off, the hyperscalers are doing their own silicon, and they're working with partners like MediaTek, Marvell, Broadcom, Qualcomm now. AMD and Intel have always said, if you have a big enough checkbook, we're willing to do custom silicon for you. So, we're seeing Huawei, obviously. So we're seeing a constant expansion of companies saying, listen, we need to adapt to the market. We need to adapt to the customers. The good thing is with the foundry services, with the advanced packaging technology, it's not cheap, but it's easier to produce a custom chip today than ever before.
Yeah, but this is where I think it is kind of an eye opener and sort of a potential warning sign for NVIDIA that hyperscalers who have large pools of value that can tap into, right? Especially on the inference front, like Google, like AWS or Amazon, right? Amazon for their internal requirements, right? These are large scale needs and demands that they can engineer where their investments in their own, um, you know, model or stack optimized infrastructure can have a benefit. This doesn't bode well. And I'm talking about the inference side of the equation, not the model training. They'll still probably, in all likelihood, for a long time, still rely on NVIDIA for the model training stuff, right? But once they figure out, okay, what can we scale out in inference and production use, they'll probably go with their own stuff. And that's probably what Apple's doing with Google. And God knows if they're probably using GPUs, NVIDIA's GPUs. They're just not admitting it.
I think they're using
You,
TPUs.
there's never been a single processor architecture for the data center. You want to know why? Because no two workloads are the same. So even if you go back 20, 30 years, you had different RISC processors, you had x86, you had
Oh,
custom
the good old
processors.
days.
For doing processing, for doing storage, for doing networking, for doing blah blah blah. I think I don't think that's ever going to change. I think that, with the level of innovation we have in our industry, you're always going to have, the general purpose solutions that are really going to be the high volume, and you're always going to have customized or, very niche solutions for other applications. But I definitely wouldn't count out anybody, especially that has the expertise, the size, the capabilities, the
Yeah.
partnership, the ecosystem, like an Intel, an AMD, and NVIDIA, because these guys, they know what they're doing. They know how to do it. And they can have multiple designs going. They do have multiple designs going simultaneously. That's the only way you can come out with a new chip every year.
Yeah. Yeah. But then, think about the Google team. They're not too shabby, right?
They are not shabby, and they are
No,
focused very specifically on their TPUs.
Yeah.
I would say that, they're definitely, and well, it'll be interesting to see. One of the things that's hard to predict right now, and it's funny because I ask this of all the tech companies, and it worries me when a CEO doesn't have an answer to this question. I ask them, okay, I know how you want to use AI, and you want AI to use your or change your company, improve your productivity, change your products and services, blah blah blah. How is AI going to change your business
That's
model? And I don't, and this gets to the heart of the point that you bring up all the time, Leonard.
Ooh, maybe.
Yes, the ROI. We don't know what the final business models of these companies are going to be yet.
Yeah, they better figure it out soon, is all I gotta say. Yeah, I mean, the clock is ticking, and so, but I mean, obviously, great point. It's that as much as they're accelerating in a 1 year cadence for their tech, they better get on a 1 year cadence in their
well,
business
and
models.
as everybody tries to
Right?
figure it out, picks and shovels are where it's at.
Oh yeah,
Right.
Yeah.
Right.
yeah, yeah,
So
yeah. But you better
and,
find some
and
of that gold
consulting
at
and
some point.
consulting like IBM, right?
Yeah.
Where they help their clients figure it out. And meanwhile, no matter what the outcome is, there's a lot of picks and shovels going into
Yeah,
Yeah.
into the field. So
yeah,
And
yeah.
and I'll be honest with you, the best answer I've gotten to that question was probably from Jensen Huang. I asked him,
mhm.
and I says, I got to credit you. You keep going after all these opportunities, and let's face it, they're like any other tech company. They've gone after some stuff like their game consoles and stuff like that that just really haven't panned out.
Sure.
But they keep evolving. And I said, okay,
Oh
so
yeah.
you went from being a chip company to a kind of a device company to being a systems company to being a service company to being a software company. What does NVIDIA look like in 10 years, especially in the AI era? And he looked at me and says, Jim, I have no idea. So
Yeah.
I mean, but the good thing is he's constantly thinking about that, and that's the
Yeah.
thing. You don't know what the business model looks like, but you have to be ready, and you have to be changing your business and your organization around, what's happening in the marketplace, what's happening with technology, and what's happening with your company.
Well, don't forget investment in VC house.
Yes,
They're becoming that as
absolutely.
well. So,
Well, and it's funny because you mentioned that NVIDIA's probably become one of the biggest VCs in the industry
yeah.
over the past year. The way with the amount of money they're making, I started a list of partnerships and investments that they've made, and I think I'm up to like 58 over the
Yeah.
past 3 years. And it's almost impossible to keep up with. They're like making
Yeah.
announcements like every 2 weeks.
Yeah. Yeah. And it's full stack. It's not just chip. It's not core
No,
technology. Like
it is
Apple.
across the ecosystem.
Yeah. Like what you see Apple do, which they rarely make. Let's say they rarely make acquisitions above their pay grade, right? It's usually technology investments and stuff like that, lower level stuff that contribute to their products and their technology foundation. But NVIDIA is like going friggin' straight up the stack all the way up to Anthropic and everything else. I mean, this is like end market platforms, right?
They're
So
investing in EDA vendors, IP vendors,
like the whole friggin'
chip
stack.
vendors,
Yeah.
systems, cooling, nuclear
TSMC.
power, blah blah blah. Yeah, everything.
Do
It's
they own
incredible.
TSMC now, or are they still a customer?
No, I was
No,
just
but
going to mention. I was just going to
well,
mention that's.
I wouldn't call them a customer. I'd call them a partner because they heavily
Oh yeah,
invest in future capacity.
yeah,
Yeah.
they do, but they don't. They have not put their toe into that water, in
No.
the
Yeah.
manufacturing water, other than providing models that do amazing things in the photolithography. But they have not built any kind of position, and I'm not sure they want to. I think for right now they're happy just to specify their requirements and how many wafers they need and go down that road.
That
Yeah.
brings
But,
up the whole Terafab concept.
yeah, Terafab. Oh,
Oh my gosh. There's like so
That
much to talk about.
there is
so
so
much
much to talk
hype.
about.
Terafab seems like a lot of hype to me. I don't think there's anything real going to come out of that, but I hope I'm wrong.
It's like one of
Actually, I
the
think I think a partnership will come out of that. I think
yeah.
eventually most of the capacity targeted towards Elon Musk's Terafab idea ends up being Intel
Yeah.
Mm.
capacity.
It's more like it's a Stargate-ish kind of announcement, right?
Yeah.
It's okay, yeah, there's a partnership. Let's see how it goes. You floated a big number or created some inflated expectations. Let's see how much of it's actually real. I mean, and that's where maybe, we don't get as excited, like you aren't all that excited about the announcement. I think that's probably a better, attitude toward these types of press releases. But really quickly, I just wanted to get both of your takes on Qualcomm's hintings here. Jim,
Mm.
you're going to be at the Investors Day. I'm going to be in Amsterdam. No, Copenhagen. I don't know where you're going to
Amsterdam. I was
be.
going to ask him what he's going to be doing, but I'm just kidding.
But some quick takes. I mean, what are you hoping to see coming out of that event in June? But what are you reading into some of these indications? 'Cause, I mean, the CPU thing was kind of new. They didn't really talk. They didn't formally announce or indicate that they're going to push out a data center CPU.
They haven't. They've kind of hinted around it.
Yeah.
So, I mean, it would be great. And this is kind of a laundry list of ideas that we'd love to see from Qualcomm. And that is that data center CPU to be paired with their AI accelerators. Definitely learning more about who their hyperscale and kind of feeling that there's more than one company they're working with right now. I mean, I know that they were also bidding on some stuff with Meta that ended up going to ARM that ended up being the AGI processor, CPU. So at least learning about that first customer that they plan on being production with by the end of the year. And hearing more about their whole IoT build out, because if you look at their earnings, especially the last couple of quarters,
Yeah.
they keep increasing despite
Yeah.
the seasonality of handsets and the projection for handsets, mostly because of memory this year. They keep increasing in IoT and automotive every single quarter.
Yeah.
That's impressive.
Automotive. Wow. 38, was it 38%?
Year over year,
Year?
yes.
Yeah, it's like at a 1.3 billion run rate or something. I think it's by the end of the year it'll be
Yeah.
about $6 billion business. So hats off to Nicole. I mean, those are the IoT stuff is tough business.
Mhm. Well, and
Oh my
IoT
gosh.
for them is kind of a big bucket. It includes
Yeah, it's a
their
big
compute,
bucket,
it
but the
includes
industrial
everything.
bit,
Yeah.
I would like to see
industrial
them
bit.
break that out a little bit
Yes.
more too. So
Yeah.
Yeah, and
it'll be
not call it
interesting to see.
IoT.
Yeah, it'll be
Yeah,
interesting
don't
to see
call it
what they
IoT.
have. Yeah.
I think Cristiano's strategy is to have a full hand of cards he can play.
hmm
And one of those cards is customization for very large customers.
Yeah.
Another card he can play is the data center AI 200, which 250, which we haven't heard anything about since
Yep.
the initial announcements. But I think we will hear more about that. I don't think it's an either or. I think it's an and.
Yeah,
And they're
it's
going
an
to
and.
both of them, as well as what, as you correctly say, is erroneously called IoT. Um, I think he's got a very good hand to play. And now this year we'll see him start to play it.
Yeah,
Yeah.
yeah, and then maybe lever. I'm really interested in seeing how they leverage the Alpha Wave acquisition of their
Yes.
assets.
Well, that's really the engine behind their customization, right?
Yeah,
Yeah.
and then the networking side of things, the networking interconnect. I mean, just how all that plays out into some of the systems that they're going to be either co-developing with the hyperscaler customer that they have.
I don't think we'll have to wait till to Hawaii. I think we'll hear more, maybe Computech. We'll hear a lot more detail from Qualcomm. So, okay, what's your real strategy here, guys?
Yeah, we have a couple of punches coming from them. First Computex, then their Investor Day, then
The Investor Day, then
and then
Hawaii.
the Snapdragon Summit. Yeah.
Yeah, yeah. That maybe they need to have a new conference.
That's what we need
They're
to
so
know.
diverse, it's like ridiculous. But yeah, I mean, and it's also it's timely given like MediaTek is making some serious inroads into the space as well. So it's, but yeah, and someone told me, oh yeah, they don't really have a presence in data center. It's like no, AI 100 Ultra. They coupled that up with Cerebrus, right? Cerebrus was using it, I think, for decode.
Yeah, I think that in terms of
of
market share, I don't think we've seen the needle move.
yeah, right. But in terms of like having done the investments, having technology, having experience, I mean, they've been working data center on the accelerator side with MPUs for at least 3-4 years, right? So, I mean, Jim, you probably have more accurate number in terms of the years, but I mean, they're not newbies. They're not.
No, they're not
There's
newbies.
a continuum here that they're riding on.
And I think their credibility has been stretched as they keep making claims and announcements that don't pan out. So I think this is the year they got to put up or shut up.
Yeah.
And I think they're going to put up. I really do.
And you have to remember that another key asset that they have here is Nuvia. Nuvia was working on data center processors. They weren't working on mobile processors. They were kind of shifted towards that when they were acquired. So, I mean, we still expect to see more coming out of that group.
Yeah. Orion. And and who knows, with all this focus on agentic and inference, I'm really interested to see how they build the MPU story, if they can find a role for that. Maybe elevate it from what we're hearing on the edge, especially on the industrial side, to the data center. So anyway, any other things you guys want to hit on before we call it?
Oh, we got to move on to May. Time to move on to May. Let's see what happens.
Oh, yeah.
Cinco de Mayo.
Cinco de Mayo.
Just kidding.
Oh my gosh, you guys. Well, hey, it was a great episode. Really great stuff. Yes, we had a little bit of a debate, disagreement. and I learned a lot from this session. So thank you, gentlemen. This has been.
I'm still looking for that slap app. So yes.
I know. We have to sign that, Karl. It's on you, man. Go and hit
I will
perplexity.
go
Figure out what that prompt is.
Yeah, we'll do a slap
How do
out.
I creep? Yeah, just send me the plugin and then I'll add. No, send it to Jim and he'll add it. Anyways, thanks everyone for tuning in. We hope you found the episode informative. Gentlemen, thank you so much for jumping on every week and sharing your wonderful insights. And if you want to tap into Karl Freund's wonderful insights in AI, quantum, and the semiconductor industry at large, hit him up at Cambrian AI Research at www.cambrian-ai.com. And he's also on Substack and Forbes. And also reach out to this purple guy.
Purple guy is more than me.
Purple
we have a whole
guy.
Team. We are the purple team.
Jim McGregor.
Yes.
How did you learn to do
Getting
that?
better?
Matter of fact, look for us on Forbes, look for us on EE Times, a couple of other publications, which I'll talk about maybe next time. And we'll be launching our own Substack channel here pretty quick as well.
Oh, awesome. Yeah, wonderful. Curious Research.
And look for our latest AI and TCO model forecast.
And you still owe us the whole Nemo Claw result, open claw stuff.
We're actually we're still working on it, and it is impressive. And we should probably have a podcast just on that.
Yeah.
Kind of share what we found.
That would be friggin' awesome. And remember to reach out at www.teriousresearch.com. And then please subscribe to our podcast, which will be featured on the Next Curve YouTube channel. Check out the studio version. Audio version on Buzzsprout, and find us on your favorite podcast platform. Also, subscribe to the Next Curve research portal at www.next-curve.com for the tech and industry insights that matter. Gentlemen, we'll see you next month and maybe even sooner on the road.
Cheers.
Take care.
Thank you.
Thanks a lot.